Hello. Today we're going to talk about graphing. So let's do an introduction to it. If you want to pause this to read the information of what we're going to be covering, the objectives for this section. Now let's move on. The Cartesian coordinate. It's actually named after Rene Descartes. He's from the 17th century, and he used mathematics. He used this graphing system to bridge the gap between geometry and algebra. So he was a mathematician. And I want to talk to you about what to look for on a graph. And whenever we look at a graph, we have a vertical line and we have the horizontal line, right? And as you notice here, the vertical line I already got highlighted in blue is my y-axis, and the horizontal line here is my x-axis. And this center point of both of those axes, they cross right here, is called our origin, and both of them are 0 at that point. Now, whenever we have an order pair, our x value always comes first because it's our independent, and our y value comes second because it depends on x. We have a quadrant 1, and in quadrant 1, we have x comma y, where x is positive value. So every number to this side to the right side of the origin is positive for x, and all the numbers above the origin is positive for y. Now, in the second quadrant here, you'll notice that we move to the left of the origin, so that means our numbers are negative for x, but our y values are still positive because it goes above it. So we get the order pair negative, positive. Now, when we talk about the third quadrant, we're still talking to the left of the origin, so x is still negative. And then we're looking at below the origin, so those values are negative for y. Now let's look at the fourth quadrant. Well, we're moving to the right, the other side of the origin, so x is positive, and we're moving downward for y. Y is negative. This is our order pair we have here. I want to do a little bit more introduction. Whenever we read our x-axis, we go from the origin to the right. These are positive numbers, so we're going out to positive infinity. When we go from the origin off to the left, they're negative numbers. That goes off to negative infinity. And we always read it left to right. Now let's look at our y values. If you go above the origin, they're all positive, so it goes off to positive infinity. If you look below the origin, it's always negative, and it goes off to negative infinity, and you always read it bottom to top. Okay, let's move on. Now, we're going to talk about plotting these order pairs on the graph. Remember, the first quadrant is always x, and the second quadrant is y. And here they gave us an example already. They said, well, let's let x be -3 and y be +5. So we're going to start at our origin, and we're going to move to the left because x is negative and it says 3. So we're going to move 1, 2, 3. And then y is positive, so we're going to go up the positive values of y, which is 5. And this is where we get our order pair. But what if we switched it? What if it was +3 for x and -5 for y? Well, we're going to go back to the origin. X is positive, so we're going to go to the right, 1, 2, 3, and y is negative. We're going to go down to the -5. Now here is our order pair. So that is graphing, and it fell. This order pair here fell in quadrant 2. This one fell in quadrant 4. All right. This next example says, okay, you're given an equation, and I want to know if a particular order pair is true solution for this equation. And if you notice here, we have 2x plus 3y is equal to 18. You notice that the power, the degrees, the exponents on the x and y are to the first power. So we have a linear equation. This means we're going to have a straight line. So what if you were given the order pair 4, 2, and we want to know, is this order pair a true solution? What I'm going to do is plug in 4 for x, 2 for y, And I want to see if this side equals that side. So 2 times 4 is 8. 3 times 2 is 6. 8 plus 6 is 14. So no, this order pair is not a true solution. And we'll go to the next slide where they have given us 2 order pairs and solved 2 different times, right? So you took the -5, comma 7, plugged it in, and you notice the outcome was not a true solution. However, 3, comma 4 was, because 18 does equal 18. So we'd say that's a true solution. All right. Now, to graph an equation, it takes, to make a drawing that represents the solution of the equation, we need 2 order pairs, right? You need at least 2 order pairs to graph a straight line. Now, so we're going to talk about our x-intercepts. So I want to go back to this graph just for a moment. Whenever we talk about our x-intercepts, basically it's saying that we are crossing, let me get me a different color here. We are crossing the x-axis. Somewheres on it, we are crossing it somewheres. Whenever you cross the x-axis, the x is going to be some number, but y is always going to be 0. Whenever you cross the y-axis, however it is, x is 0 and y is some number. So if you remember that, it says intercepts. That's what we're talking about. We're crossing their axis. So in this next one here, it says, it's just letting you know that y is 0 whenever we cross the x-axis. So let's take that same equation and let's plug in 0 for y and find out where it actually crosses the x-axis. So now I have 3 times 0, that goes to 0, right? Leaves me with 2x is equal to 18. Now, in order to solve for x, we need a +1 coefficient on x, right? In this case here, we have a +2. And to undo this multiplication, we are going to divide by that 2, because 2 goes into itself once. What you do to one side, you must do to the other side. So now I have 18 divided by 2, which is 9. So it crosses the x-axis at 9. That is my intercept. As you see, it's worked out for us. Now let's talk about our y-intercept. So we're crossing the y-axis. That means x is 0. So we're just going to plug in 0 for x and find out what y is. And it did it. Well, let's do it before we scroll down. Sorry. So I'm going to plug in 0 for x. 2 times 0 is 0. I get 3y is equal to 18. So again, we need a +1 coefficient on y in order to tell you what y is equal to. And it's a +3, so I'm going to divide by 3, right? 3 goes into itself once. What you do to one side, you must do to the other. 18 divided by 3 is 6. So this order pair is 0, 6. It crosses the y-axis at this point. I just want to do a little side note. If it would have been a -3, y equals 18, we would have divided by -3, because negative divides negative is positive, right? So that was just a little side note. So as you can see, it's worked out. And now this next example said, so now we're going to graph this on our Cartesian coordinate, right? So we're going to graph here where x is 9, plot it because it crossed here, and we're going to plot where y is 6, it crossed here, and we're going to connect it and put arrows on it. So we noticed that on this side of the y-axis and this side of the x-axis and everything in the middle has infinite many solutions. And the reason why I said infinite many is because we got these arrows on each end and it's going to continuously go on. So I'm going to just pick a value for x and plug it in and find out what's my value for y. And that gives me a solution somewhere on that line. Okay, and as you notice in this next example, they plotted it for you here and it's labeled. And then what they did is they created an x and y table. So they plugged in 0 for x, came out with an outcome for y. Plugged in 0 for y, got an outcome for x. Plugged in 3 for y, or excuse me, x, and got an outcome for y. And then this last column is our order pair column. They wrote it in order pairs to plot it. If this works for you, I would encourage you to use this method. Now, we were talking about straight lines, right? We're talking about linear equations, but in this one here, what do we see? We see that we have x squared. So we have something different going on here, right? It's not a straight line. It's actual a parabola. And whenever we have that squaring, we know it's going to be a parabola. And the parabola opens upward if the value right here, the coefficient on x is positive. If the coefficient on x is negative, it's going to open downward, okay? So now let's solve for it. Well, if the factoring method doesn't work, we're going to use the quadratic method. Now let's talk about this right quick. When I talk about factoring, there's two options. Well, actually, there's more than two options, but I'm going to show you the simplest, straightforward method. So whenever we see we have a quadratic going on, we know that the quadratic is written in the form of ax squared plus or minus bx plus or minus c, where a is the coefficient on our x squared, b is the coefficient on our x to the first degree, and c is my constant. Now, when we read this, we want a to be a positive 1 to start solving the factoring method. It makes it a lot easier. It doesn't always come out to be positive 1, but it does make it easier. However, the sign on C tells me if we're adding and subtracting the product, and B is telling us the sign we're using. So in this example here, C is negative. So this tells me we're subtracting a product, and product means multiplication, of A times C that equals my B. And whatever B is plus or minus. In this case, B is negative, right? So it's going to be a negative B here. So let's see if we can factor it. So my A in this case is 1, my B in this case is negative 9, and my C is 12. And I know it's a negative 12, but the negative sign in this case here is telling me we're subtracting. If we're subtracting, we have a difference of signs. That means we are going to have a plus and a minus. If it was adding, then it would have been both negatives, or it would have been both positives, depending on what B is, right? So in this case, it's subtraction. So we have a difference of signs. Since B is negative, the larger of the numbers will be negative. So let's take A times C. So it's 1 times 12, which is 12. Let's list our products of them. All right, so I listed all the products. That's going to give me 12 when I multiply them together. Now let's keep on reading. It says that subtracts, because the sign on C tells me we're subtracting, to get negative 9, which is my B, right? Well, if I say 1 minus 12, well, that don't equal negative 9. I could say, well, 2 minus 6. Well, that don't equal negative 9. 3 minus 4. And if you notice, I put the negative sign on the larger numbers because this is what it's calling for. B is negative. Then, and we don't have an outcome. So this doesn't work. Since it doesn't work, I want to use the quadratic method, quadratic formula. So give me a second. Let me clean this up. Let's use it. Pen. There we go. So that is x is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. Well, we already listed what a, b, and c is, so let's plug it in. So we got negative b, which is negative 9. So minus that negative 9, plus or minus. I'm going to put the negative 9 in parentheses, squared plus minus 4 times 1 times 12. Or excuse me, negative 12. We have to, and let me rewrite this. I didn't give myself enough room, so it makes it hard for you to read it. So let me come underneath down here. All right, negative times that negative 9 plus or minus again, I'm in parentheses for the b squared because b is -9 and we're squaring it. So that negative gets squared as well. Times +1 for A times -12 for B, all divided by 2 times A. So let's clean it up. This negative times this negative is a positive. -9 squared is going to be 81. 4 times, excuse me, it's a -4 times that -12 gives me 48. And it's positive, right? Because negative times negative is positive. Divided by 2 times 1, which is 2. So now I got 9 plus or minus the square root of 81 plus 48, which is 129, divided by 2. So we have two solutions here. I'm going to write one here. We have x is equal to 9 plus the square root of 129 divided by 2. And then we have x is equal to 9 minus the square root of 129 divided by 2. So I'm going to use my calculator because I don't know the exact value for square root of 129. And it didn't give me the exact. It's actually not a perfect square. So I got 9 plus that square root of 129, all divided by 2, gives me, I believe they are rounding their values, but it did not give, it gave me, I'm going to do approximation. So I'm going to use the squiggly lines, and I'm going to round to the nearest tenths. So it gives me 10.2 for my x value, and then do the same for this next one. So I get a -1.2 approximately. And so now we need, that gave me my x-intercepts, is where it's crossing the x-axis at. And they actually picked different order pairs to come up with these values because it gave us such a yucky looking intercept. But you want to find where it crosses the y-axis. So that's going to be the easiest. So what we did here is we actually solved for the x-intercept. So I got 10.2 comma 0, and I got -1.2 comma 0 for my y. Now that's my x-intercept. Let's find my y-intercept. So let's plug in 0 for x. If I plug in 0 for x, it leaves me with y equals -12. That came out to be really pretty. See right there. So now I got order pair 0, -12. So in this section here, they said, oh, let's make it easier on ourselves since our intercepts are giving us such a yucky number. And plus, it didn't ask for you to solving by the intercept, but I was solving the parabola. And this is the method you usually go. You factor it down, find where it crosses x-axis and the y. And then you can find other values on it. You can find its vertex. You can find order pairs that happen. But we'll get to that, okay? Keep it simple. If you have any questions, please reach out to me. This next one says, we're going to use the distance formula. What are we doing? We're trying to find the distance between two order pairs. So, of course, the parabola, I wanted to come back here. I was just going to tell you, what if we wanted to know the distance from this order pair to this order pair? We're going to use a specific formula. So this formula is this right here. So I encourage you to pause this video, write it down. It has this x subscript 1, y subscript 1. This just says that it's the first order pair. X subscript 2, y subscript 2 is just telling me it came from the second order pair, okay? And here's a picture of it. So you have this order pair and this order pair, and we're trying to find the distance between them. This is where they came up. You can use this method here too. It's really a great method. Now, I don't want to show you all the math work. So I wanted to take this order pair. So we got -2, 2, 3, -6. And let's find it. So we have -2, 2, and oh, my apologies. No, it was 3, 6, 3, -6. Okay. All right. So we're going to call this x subscript 1, y subscript 1. x subscript 2, y subscript 2. And we're going to plug it in. So I got the square root. I got -2 from the first order pair. Oh, excuse me, guys, excuse me. See, it happens. I got in a little bit of a hurry. And my eraser is not wanting to work again. Been ornery. There we go. Now, let's do this. My x from the second order pair is a +3 minus my x from the first order pair, which is a -2. So I put it in parentheses because I have this minus going on. And negative times negative is positive, right? So now I have 3 + 2 squared plus my y from the second order pair is -6 minus my y from the first order pair, which is +2. So I'm going to bring it all down. -6 minus 2. That's like saying you're in the hole $6 and you spend $2 more. So you're in the hole even more. So it's a -8 squared, and it's going to square root it all. Now, I got 3 + 2 is 5, and I got 5 squared. I got +8, and it's not just 8, it's a -8 squared. Well, negative times negative is positive, so if you want to square it, it becomes positive. So that means I got an 8 squared. 5 squared is 25, 8 squared is 64. When I say squared, that means we're going to say 5 times 5. 8 squared is 8 times 8. That's what this subscript here, this is not a subscript, excuse me, the power means. So I have 25 plus 64. So now I have the square root of 89. Now I'm going to see if it will clean up and factor down. In this case here, it does not. So this is my exact form. You will put it in decimal form if it asks you for decimal form. If it asks you to round to, like, say, the nearest, let's just say hundreds. And I get this decimal number of 9.43398, so on. And I want to talk to you about rounding just for a second as a refresher. So say it wanted you to round to the nearest hundreds. As you notice, the second decimal place is the hundreds. What we do is we look behind that number and we ask ourselves, and believe me, sorry, my apologies. It's just a simple yes or no. We ask ourselves, is it equal to or greater than 5? If it is greater than or equal to 5, then we add 1 here and drop the decimals. If it's not, we just drop the decimals and leave it alone. In this case here, it's not. So my answer is 9.43 approximately. The square root of 89 is the exact. Okay, so be sure and read the instructions. And this worked out for you, and you can plot it. Now, let's talk about the midpoint. The midpoint is the halfway point between the two order pair. And again, we have the subscripts 1 and subscript 2. It's just labeling each order pair. And here is our formula. It looks like this one got cut off. Put a comma. And again, our x values are our first order pair, and our first coordinate in the order pair, and our y values the second in the order pair. And let's see, we're going to use this these order pairs right here to solve. So if we're going to do x1 plus x2 divided by 2, I'm going to do it separately. You don't have to, but I am. So my x from the first order pair is -4, and plus my x from second order pair is 2. -4 plus 2. So it's like saying you in the hole $4, you deposit 2. So you're now in the hole $2. And then we got +2 divides -2. Positive and negative in division becomes negative. 2 goes into 2 once. So now I know my first coordinate in this order pair is 1. Now let's find the y value. Okay, my first order pair y is -2 plus the second order pair y value is 5. And I got -2. So you're in the hole $2, but you deposit 5. So that means we have 3 left. And we divide it. It gives me a fraction. Do not take it out of fraction unless it asks for you to round your decimal to a specific point. Okay. Be sure and read the instructions. So this is my order pair. And you can plot that point where it's halfway. As you see here, it's worked out for you. All right, let's talk about circles. Circles are fun, and you can be. If you notice, it's similar to the distance formula. So whenever we talk about a circle, y'all notice that we're calling the X and Y now H and K because it's representing the circle. The H is still X and the K is still Y, but we're talking about the center and we're talking about a particular point. So we need to separate so you know you can acknowledge which part is it. And then my R is going to stand for radius. Radius is from the center to one point of the side. It's just the halfway point. If you went all the way across the circle, that's a diameter. And whenever we're trying to figure out particular points on circles, we talk about the radius. So be sure and read what it asks for. If you were given the diameter, it's seen to be divided by 2, because it makes sense, right? Because the radius is half of the distance. It's from the center over. Okay. So let's solve one. Let's see the order pair it gave us. So, oh yeah, here's the formula and it's solved here. Okay, so let me talk about what it showed us up above, because they said when you find the radius, when you're trying to solve for the radius, if you don't know what it is, you're using the similar formula to the distance formula. So here it is. Here is the actual formula for the center. So you have your X minus the H. Remember, the H is the X value from the center, Y squared plus Y minus K, and K comes from the center of the circle squared is equal to R squared. So if we were trying to solve for R, then to undo the R squared, we do the square root, right? In order to do the square root, you have to do it to both sides. You can't do it to part. And that's where they came up with the R equals square root of the X minus H squared plus K, or plus Y minus K squared. So that's where they came up with that, solving for the radius, because sometimes you need to figure out what the radius is, and all you got is XY order pair on the circle, and you got the center, and so you can find out the other information. It's pretty fun. You can go back and forth. So let's see what example it's going to give us. Okay, so it said we have a radius of 5 and we have a center of 3, -7. So I can write that in the formula. So my radius is 5, right? And then it said -3, 7 is my center. So I have X minus, and I'm going to put the -3 in parentheses, plus the Y minus that 7 because it's positive. And let's clean it up. Negative times negative is positive. So now I have this. And we can actually plot this on the graph. And 5 squared is 25 because you can't leave it as just 5 squared. And that is my center, or my circle formula, my equation of a circle. Oh, and I had my negative signs. I switched them, but that's okay. So here's another example. Thank you.